In this class, we are going to look at the volumetric analysis calculations. So, we are going to take this question as our case study. You have a solution of hydrochloric acid A and then a solution of 0.05 mole per dm cube sodium carbonate. The solution of the acid was titrated against 25 cm³ portion of the sodium carbonate using methyl orange indicator. The experiment was repeated to obtain a consistent titers, and the table of result is given below. Here is the table of result. Okay, if you look at the table of result very well, the volume of acid yields are yet to be determined, but the raw result obtained from the titration, they are presented in the table. Yes, that was done deliberately. Okay, how do you now get the volume of acid used? It is going to be the final volume minus the initial volume. If you do that, then you are going to have this result. Okay. For the rough, you are going to have 20.20. For the rough, you have 20.20. Then for the first reading, you will have 20.10. Remember, titration results are presented in 2 decimal places. Okay, for the third, you are going to have 20.50. That is 20.50. And then the last one, you are going to get 22.00. That is 22.00. Okay, these are the result of the titration carried out. Now, what are we going to do with this result? First, we are going to use it to calculate the average volume of the acid used. And for you to calculate the average volume of the acid used, you need to make use of concordant values. When we talk of concordant values, these are values that their difference are not more than plus or minus 0.2. So values that are no more than plus or minus 0.2 are referred to as the concordant values. Okay, now let's calculate our average from this result. We have only 2 values that fall under this range, and they are 20.20 plus 20.10. Since we have 2 of them, we're averaging, we divide by 2. Okay, the moment you have done this, you are going to get 20.15. The unit is very important, centimeter cube. So that is how we calculate the average of the acid use. Okay, now having gotten our average, we are going to see the other problems that are involved when dealing with volumetric analysis. In fact, there are lots of problems and we are going to be doing them one after the other. And so, if you want to see all this method of calculation, you are going to click the subscribe button so that you will be notified anytime any of the video is being posted. So now, let's quickly look at the other set of questions that are involved when carrying out volumetric analysis. Here we go. Okay. Now, the equation for the reaction is given. You can see sodium carbonate combining with 2 mole of hydrochloric acid to give us 2 mole of sodium chloride, and then 1 mole of water and 1 mole of carbon dioxide. So we are going to use the information from the equation and the average volume of the acid we obtain from the titration result to carry out the following calculations. Number 1, we are going to calculate the concentration of A in mole per dm cube. For you to carry out this calculation, there are 3 steps that are involved. Because if you look at the question very well, you will discover that the concentration of A is not known, and the only thing that we know from A is the value that we calculated from the titer values. So now let's calculate the concentration of A in mole per dm cube. First thing to do is to calculate the mole of B. So we are going to calculate the mole of B. Okay. The number of mole of B. Okay. So we can calculate the number of mole of B by multiplying the concentration and the volume. That is, number of mole of B equals to concentration times volume. Concentration times volume. From the question, we were given the concentration of B to be 0.51, and then we were told the volume of the pipette to be 25 cm cube. Yes, If you go directly this way, you are going to get a wrong answer. So you have to change the volume of the base, the volume of pipette, to dm cube, because it's right now in cm cube and it should be in dm cube. How do we do that? We divide it by 1000. That is, divide by 1000, so that we now have 0.051 times 0.025. Okay, so we have now have a uniform unit for both the concentration, which is in mole per dm cube, and then the volume of the pipette have also been changed to dm cube. So if you multiply this, you are going to get 0.01275. This will be 0.00125. Okay, you get that as your answer. But we need to be very careful here. In carrying out this calculation, it is advisable to leave your answer in 3 significant figures, because exam bodies penalize those who did not meet up with this standard. In that case, our answer will become 0.0128 mole, and your unit is also important. Okay, so we have gotten the mole of B, and that is what we have as 0.0128. So what we need to do right now is to use this and calculate the concentration of A in mole per dm cube. How do we do that? Let's look at it. Okay. In order to use the number of mole of B to calculate the number of mole of A, we need the equation, that is the stoichiometric ratio of B and A. So A to B is 2 of A is obtained from, let's do it this way, that is 2 mole of A. So is obtained, that is 2 mole of A is obtained from 1 mole of B. So 2 mole of A is obtained from 1 mole of B. All right. Then we have calculated the number of mole of B to be 0.00128. So that is what we calculated to be the number of mole of B. So what should be the mole of A? So all we need to do is to cross multiply, so that you now have your mole of A equal to 2 times 0.00128, and This is going to give us 0.0256. That is 0.0256 mole. Yes, so that is how we get the mole of A using the information we have about B. Now, having known the number of mole of A, how will this help us to calculate the concentration of A in mole per dm cube? Let us look at it. All right, recall, we said earlier that concentration, as we said earlier that mole is equal to concentration times volume, and what we are looking for now is concentration. So we can simply say concentration is equal to mole over volume. Concentration is equal to mole over volume. Now, we know our mole and we also know our volume. Our volume is the average titer that we calculated earlier to be 20.15. So we can now put in this value here. The mole we calculated was 0.0, calculated it to be 0.0256, 0.0256, and then our volume, average volume of acid we calculated was 20.15. Remember that this value is in centimeter cube and we need it in dm cube. Okay, so changing it to dm cube, we are going to divide it by 1000. So when you divide it by 1000, you are going to get 0.0215 as your answer. This will give us 0.0215. That is it. So we get 0.02015. Okay, so we plug in the value here, which is 0.02015. So this is in mole and this is in dm cube. It is simple, mole per dm cube. So we are going to divide this value. We are going to divide this value, and when you do that, you are going to get 1.26. 1.26. That is your answer. Intrinsic number, that is mole per dm cube. That is how you obtain the concentration of the acid in mole per dm cube. Okay, now having gotten the concentration value, there are other calculations that we can carry out from here. Let us look at that in our question. Let's go to question. Okay, that is question number 3. If you look at question number 3 carefully, it says we should calculate the volume of carbon dioxide given off as a cause, at the cause of this reaction. Okay, what do we do? Volume of carbon dioxide given off. Yes, this is another simple aspect in carrying out volumetric analysis calculation. Our center point is always the number of mole. To calculate the volume of carbon dioxide given off, you can do that using the number of mole of the acid or using the number of mole of the base. But since I started with the number of mole of the base, I'm going to use that to calculate the number of mole of carbon dioxide. So you calculate the number of mole of carbon dioxide and then you make use of the number of mole to calculate the volume that is needed. So as long as you can calculate the number of mole, then you have no challenge. Let's look at this using the stoichiometric value. Now, 1 mole of B yielded 1 mole of CO2. Now, since 1 mole of B yielded 1 mole of CO2, it means 0.00128 of B will also be equivalent to that of carbon dioxide. So our number of mole here will be 0.00128. So we have that to be our number of mole. So you just look at the equation carefully. You will discover that the stoichiometric ratio of B to carbon dioxide is 1:1. So it means 0.0128 mole of B will also give us 0.0128 mole of CO2. Now that we have gotten the number of mole of CO2, how do we go about calculating the volume? So it is simple. Now, volume, guys, let's look at it. Mole is equal to volume over 22.4 dm cube. Now, 22.4 dm cube is the molar volume of all gases. That's the molar volume of all gases, and we are going to use that to calculate the volume of carbon dioxide given off. Now, for us to do that, we know our mole to be 0.00128, and then we don't know our volume, and then our molar volume is 22.4. That is 22.4. So our volume is going to be 0.00128 times 22.4, going to be 0.0128 times 22.4. So if we do that, our answer is going to be 0.0289. So we're going to have 0.0289 dm cube. So that is how we make use of the number of mole to calculate the volume, and we also make use of C to calculate concentration, as long as we know the other parameters. I know this is pretty simple, and like I said earlier, I will want you to click the subscribe button so that you can be getting notifications for my videos. So see you in the next class, and we are going to have more of the calculations on volumetric analysis. Thank you.